Actually, in this session, I am going to discuss some based on linear differential equation of the first order. But don't forget to view and subscribe after the session is over. Okay, fine. Just see. The sum is here. Cos x dy by dx plus y sin x is equal to 1. Okay. Here we shall divide both sides. Dividing both sides with cos x. Okay. So what we have here, dy by dx plus y sin x by cos x, it becomes tan x, and 1 by cos x, it becomes sec x. Okay. And what we have to do now, it becomes in the form of the linear differential equation of the first order. Okay. So what we shall do here, we shall find the integrating factor here. Okay. So integrating factor is here is equal to e to the power p dx is the formula. This is the main actually expression. So e to the power, the value of p is here. One step I have shown you to remind the actually the linear form. Actually the value of actually here p is, that is 10x. Clear? So that is e to the power log sec x. Okay. C is not used to write here. Constant of integration is not used to write here because it is in the place of the exponent or power. So it is not required to write here C. Okay. E and logarithm is cancelled out. So what is left here? Sec x. The integrating factor if becomes sec x. Okay. Now actually this is equation number 1. I can put now multiplying both sides of differential equation 1 or equation equation 1 with integrating factor if is equal to sec x. Okay. So what we have here, that is sec x dy by dx, sec x dy by dx, and this will be y sec x tan x, that is equal to sec square x. Okay. Clear? We can write this in this way: ddx of y into integrating factor. What is the integrating factor here? Integrating factor is here 10x. Okay. And this is here sec square x. Okay. This is here sec square x. Okay. One thing I can do here, in this step I can do directly here. This becomes as ddx of this. If I will go through the differentiation of this, keeping y fixed, keeping y fixed, uh, actually ddx of yeah, keeping y fixed. If I am actually ddx of this, okay, y into integrating factor, y into integrating factor. Sorry, this is actually y into integrating factor is, what is integrating factor here? Integrating factor is here sec x. Okay, so if I am keeping y sec x fixed, then dy by dx, and if I am keeping y fixed, then the derivative of sec x is sec x square. Okay, so in this way you can understood. Okay, and this is t d of y sec x, y sec x, d of y sec x. Sorry, this is, I am correcting here little bit. Y sec x, d of y sec x. Okay, fine. And this becomes here cross multiplication. Dx is multiplied with d. Here dx is multiplied with this, and this becomes here integration. Okay, integration sign you will put here. D integration, d and actually derivative and integration uh, inverse of each other. Derivative and inverse integration. Derivative and integration are inverse to each other. Derivative and integration are inverse to each other. So what is left here? Actually, a star followed a star. You just see here, I am just separating this actually part. Star will continue from a star. You just see here, actually d and integration are inverse to each other. So what is left here? Y into sec x. Y into sec x, that is equal to sec square x dx plus c. Because I have integrated in the left hand side, that is why I have put here c. Okay, constant of integration. Okay, why I have done so? Because I have integrated in the left hand side, that is why I have put here c. Now it becomes here y sec x is equal to, and sec square integration is actually here tan x plus c, and actually I am writing here or, and this become the solution of the given differential equation, is the required solution. That's all of this session. Okay, fine.